What's up, everyone? Today I'm going to show you how to reverse engineer a Linux executable, and we are going to do that in Kali. So the tool we're going to use is called Radare2 or Radar2. I'm just going to call it R2, but we're going to use that to crack this crack me executable here. So let's take a look at this executable. First thing I like to do is just run it. Obviously, if it's malware, it'll break your system, but I have snapshots enabled on my virtual machine, so I'm not afraid to run it. So let's run this. Alright, it says enter the password. Obviously, this means anything could happen, but we can try 1, 2, 3, 4, 5, 6. Obviously, that doesn't work. We can do please let me in. Obviously, that also doesn't work. So you can see we cannot really brute force this because otherwise it would take forever. There has to be a better way, and there is. It's called reverse engineering. So to begin the reverse engineering process, let's take a look at what strings lie inside this executable here with the strings command, which is shipped, I think, in pretty much all Linux distributions. Alright, so here are all the strings inside this. Many of them are C++, looks like C++ template symbols, linker symbols. But here are something interesting. So we have the enter the password prompt, logging successful, logging found, and then some weird symbols like this. Maybe these are the passwords. But rather than trying all of them, there's actually a faster way to do this, and of course that is using R2. So let us use R2 to crack this executable. So to do that, we're just going to type R2 crack me. And then we are inside the R2 prompt. Let us try to double analyze this to get all the information we need. So that's just 2A, so double A. Enter. It will analyze all the flags, imports, entry points, symbols, and obviously variables. So we have all this done. Okay, now let's look at all the functions that are inside this crack me. So to do that, we can do AFL, so function listing. And there is a lot of functions. Most of them looks like to be C++ libraries, especially input and output. I see the output stream, character basic string. So there's too much. But what we do want to look at is the main function, because I'm pretty certain that this type of executable has a main function, especially for a console program like the one we just seen. So we can do that by just doing AFL, and then grep also works normally. So we just grep for main. And we found main. So main is in the offset 1428, and that of course is in hex. So let us go there. So to go to that address, we just set it to 0x1428, and you can see our pointer changes to that address. And now we are going to disassemble it. Let's just see what's going on. All right, there's a lot of things going on. And this is obviously the disassembly. So we immediately see these strings appear again. So logging successful is offset 2023, and then 2034 is logging failed. And of course, there's a test instruction and then a jump instruction. So I'm assuming this is like the jump if it's correct, and then if it's not, then we go to logging failed. But there's actually a better way to look at the main function besides disassembling it, because this is kind of hard to read. So the other way to do it is by typing pdd, which is decompiling it. It'll give you a pseudocode, sort of like C, but not really, because we know that it isn't really, like C isn't really reversible in this manner. But it's pretty close. For example, we have the return type function. The syntax looks about correct, but everything else is still in terms of assembly and register. So you do have to think about that while you're doing it. All right, so let's look down here, and there we go. We have this register. If it doesn't equal 0, logging successful, else logging failed. So we definitely want this to pop up. And because this doesn't equal 0, I'm assuming that AL should be a boolean. And oh, look at this. AL is set to sim check password, which is a function. Obviously, it's cut off there, but you can see it's a function with the parentheses right here. All right, so let's try to find this check password, because it seems promising because it's named, and we can go back to our AFL again. But obviously, we are just going to grep for this check password. And there's two of them, but obviously this one has more bytes seems more substantial, we're going to use this one. So that is offset 1275. So let's go there. S0x1275. And we are here. Obviously, PDD to disassemble it. Decompile it. And we are back to this again. All right, this seems a lot more, yeah, check password. So this seems probably like the main area that we need to dig around. So I like to open up a simple notepad or mouse pad, and I'm going to zoom in here. We're going to keep track of some things here. Obviously, we can also rename variables, but we want to keep track of certain memory addresses, such as this one, and we want to see kind of like what's in there. And to do that, we can go back to a disassembled version of this by typing pdf, and then this might look messy, but it does have these nice comments for you to look. So first thing we're going to look is, remember, we're going to compare this versus the pseudocode here. First thing we're going to look at is this 0x2005 address. And that, of course, is the string literal DEC. So that's pretty useful to us. So let's type that. So we're loading effective address from this address, of course, to RSI. So that's just equal to RSI equal, wait, did I create another one? There you go. RSI equals DEC, and then we can say 0x205. All right, next thing, let's see, any more string literals? We have a single character K at offset 2009. All right, let's record that. So what's that? It's also RSI, but it's probably a later register. So we're using the same register, but it's probably cleared and reused again. So that's why we put the memory address again. So memory address is 2009. And then finally, I see this card down here. CAR, also RSI. So RSI seems to be kind of like loading the strings in. And that is in memory address 0x200B. All right. So that's pretty useful for assembly, because it tells you what these addresses are without you having to go look, which is definitely very useful. All right, the rest of these, I'm sure if you're familiar with assembly, you can deconstruct it, but let's go back up to this because this is sort of easier to read. All right, so we know that it's loading this right here. This right here, and we want to see what it's doing with it. So first thing it's probably doing is, let's see. Okay, so AL is the boolean, and that's checking if RDX equals RAX, and RAX up here is equal to this bar underscore 68H. So we should probably rename this to something useful. But I don't know what that is yet. However, down here we do see this do while loop. Yeah, while true, we set EAX to 0. If EAX is greater than this, then we go to label 1. Otherwise, we decrement EAX. Honestly, this kind of looks like a for loop. I'm getting the vibes of looping up to some certain value or certain range, stopping, and then going to either label 1 or label 0. So label 0 has this return function. So I'm assuming label 0 is what happens when it's done. Label 1 just seems like the body of the loop. Because again, if it's greater than this, then we go to, and then it decrements it. So it's gonna reach 0, I presume, and then it's going to probably exit. All right, let's take a look at label 1. Label 1 is a so we do see this bar 68H here again. This might just be bad decompiling, so I'm ignoring that. But I do see this reverse function. So this is a C++ function that just reverses the string of whichever thing you give it. So, for example, DEC, if you pass that in, it'll become CED. So that's pretty simple. So RAX is this function right here. RBX is RAX, but then RAX is set to this. So okay, so these are two basic strings. I'm assuming they're crafting strings out of these because RSI is loaded up above, and then we kind of do this. So we load it into RSI, RDI, and then boom, make a string out of it. So that's kind of like what I'm getting at right here. And then now we know it has to do something with the order of D, C, K, and CAR, but I just don't know what. So we can kind of start testing this right now. So first thing we're gonna do is we're gonna open up a new terminal. We're gonna go back to our downloads folder, and we're gonna run this crack me thing again. So let's just run it as is. So DCKCAR, that card, that is wrong. All right, but we do know it's also reversed. So we can do RACKCED. Whoops, I need to run that first. RACKCED, also wrong. All right, so that means it's doing more than just reversing the basic things. All right, let's see what else it's doing then. So going back here, we see that there's a few things after when it calls label 1. So label 1 is only met when this is greater than that. So I'm assuming this, we can actually, let me try rename this here. I think AFVN, which is also, let me check. Yeah, AFVN is renaming a local, new name, old name. So new name comes first. So we want to name this bar 1ch. I think it has to do with perhaps I think it has to do with the length of the string, I believe, because that's what it looks like from that for loop. So I can say, for example, we can do size of string or password, and then the old name is bar 1ch. All right, now disassemble it again. Going up here. Yeah, so if EAX starts from 0, greater than, but I'm not really sure why it's decreasing. So okay, let's assume that it doesn't go to, it's not greater. So 0, oh, and then it sets EAX to the side of the password. Okay, that makes sense. And then it subtracts it. And then if this equals EAX, then okay, I think I know. So this, remember this, if we open this, keeps on opening a new. 2009 is K, 200B is car, in that order. So this creates K, this creates car. But bar 60H is recycled, its address is recycled. So I'm assuming bar 60H is the actual password, and it's kind of like building a string and then shoving it back into this address, or I guess in familiar terms, concatenating. But that is okay. So it definitely concatenates K before car. So we know that something this happens. But now we just gotta see what this if, like how this if statement is triggered. And that, of course, we need to look down here. EAX equals bar 14H. And then this seems like building another string again. Let's just see. Okay, so we have DEC something something K car. Uh, I'm wondering. Okay, so let's name first of all. Rename var 14h here, and we will rename it to size, or I guess trigger K card var 14h. All right, so I'm just naming it based off of what I think this is, because this is definitely K and this is definitely car, so we know trigger K car. So trigger K car equals 0 up here. And then I don't think it gets set again. It may be set down here. Okay. Trigger K car is going up. So now I'm thinking that this EAX is probably just the size of the password. This is actually the incrementer. But trigger K card is going up, and then when it hits, it's going to add it. But then EAX equals size of password, and then -1. So I'm assuming let me just write some pseudocode so you guys get what I'm kind of trying to say here. So EAX, I'm going to use C++ notation. So password or something dot size, and then EAX minus minus will become password dot size -1. So that's essentially what it's kind of trying to say. And then if trigger K car equals EAX, which equals password dot size -1, then it will append K car. So we just have to figure out what this size of password is, because I don't think this is actually the size of the password. This might be the size of the DEC, not gonna lie. That's what I'm getting at here, because it's creating this DEC string from this offset, and then I think it returns EAX. You know what? I do think this is the size of DEC. Just that offset. Yeah. All right. So we can replace. So that means EAX is 2, and when trigger K car equals 2, then we insert K car. So that means that when you're looping through the DEC string, and when the iterator goes to 2, which is, I guess, before this last one, we add K car. Okay. And then obviously down here we have to, where is it? Reverse this thing. Let's see, CRACKEZ. Oh, wow! I did not expect that. All right, so crack. All right, this seems like a legitimate password. I guess, I don't know. It might be wrong. We can continue if it's wrong, but this seems right. So cracked. And we do like that. Login successful. So cool. All right, my intuition of this whole for loop scenario was correct. All right. So yeah, there you go. There is how you can crack a executable using R2 by looking at the disassembly and the decompiled pseudocode to kind of like guess and test your way around things. Hopefully you enjoyed this video. Please leave a like and subscribe, and I'll see you in the next one.